In this next video, we're going to talk about the domain of square root functions and also how you would go about graphing a square root function. We've talked about domain before when we were dealing with fractions. I know that was a while ago now, but a fraction has a domain restriction when the denominator of a fraction is 0. And we learned how to take a fraction and focus on that denominator and set it equal to 0. With square roots, we have a very similar approach, but what you do is you take whatever is under, that's the key here, the square root, and set it to greater than or equal to 0. And the reason you do that is because under the square root can never be negative. It can be 0 and it can be bigger than 0, but it can never be negative. So by setting it to greater than or equal to 0, it makes sure that whatever you plug in is always going to be the correct result. What else is I going to add? The key though, and what I've run into in the past, is you have to remember to do greater than or equal to 0. Because, and you have to remember to do only what's under the square root. So if you look at these first two examples that we're going to do together, I know in a previous semester this caused a lot of issues because students, they were setting, like in number 1 here, they were taking x minus 6 and setting it to greater than or equal to 0. And then when they were coming over to this one, they were taking x plus 8. But remember, the directions say only what's under the square root. This plus 8 is not under the square root. So when you do this one, you would just do x is greater than or equal to 0. This one is done because x is already by itself and there's nothing you can do to solve this. This one, however, has a one-step solve where you would add 6 to both sides. And you get x is greater than or equal to 6. And x is greater than or equal to 0. This just means that whatever you plug in has to be 0 or larger. Because if you plug something in smaller than 0, that would be a negative number, and you can't plug in a negative. This is saying that you can plug in 6 or larger. So if you put 6 into the original problem, 6 minus 6 is 0, and the square root of 0 is 0. If you plug in 8, let's say, 8 minus 6 is 2, and then you could take the square root. But if you plug in something that's not larger than 6, like 4, let's say, 4 minus 6 is negative 2, and again, that would cause a problem. Now, the way they want you to write these answers out, though, is in what we call interval notation. So I've talked about this as well before, but I'm going to review it here briefly with a number line. So I'm just making a sketch of a number line. To put x is greater than or equal to 6 on a number line, you would put a solid circle on 6. And because it's greater than, you would shade to the right. And that's how you would graph that. I'm also going to graph the second one here, and then I'll show you how I do interval notation. I would put a solid circle on 0. And the reason they're both solid circles is because it's greater than or equal to. And anytime it's greater than or equal to, it always gets a solid circle. That means included. It's also greater than again, so I'm going to shade to the right. Now with interval notation, I ask you to take your two hands, left and right, one finger on each hand. I am going to put my left finger, which you should be able to see here, on where the number line starts, and my right finger on where the number line ends, which happens to be an arrowhead. So I am going to write down wherever my left finger is 6, comma, wherever my right finger is. An arrowhead on the right-hand side is infinity. Means it's going on forever and ever. So my left finger and my right finger, 6 and infinity with a comma in the middle. Anytime you have a solid circle like the 6, you put a bracket. Anytime you have an arrowhead or an open circle, you automatically use a parenthesis. So I'm going to write that up here at the top and I'll show it to you. Brackets are for solid filled in circles. Parentheses are used when we have infinity, negative infinity, or an open circle. So the only time, and I'll save that there for a second in case you wanted to copy it down, you could also pause. The only time I would have a double parenthesis here and here is if I have an infinity and then this had been an open circle. The only time I would have two brackets is if this was a solid circle and there was another solid circle on the right. So for the second one, same thing. My left and my right hand, one finger from each, 0, comma, it's going to the right again. This is positive infinity. 0 is a solid circle, so it gets a bracket, and the arrowhead would get a parenthesis. And in ALEKS, there's options on the right-hand side for you to pick the different scenarios, like 2 brackets, 2 parentheses, 1 of each. And then I have one more here, letter C. It throws one thing into the mix. So first step is still the same. If we're looking for the domain, and remember, the domain just means what can I plug in? What are possible values of x? I'm only going to take what's under the square root. The -7 doesn't matter. I'm going to set it to greater than or equal to 0. And now this one is almost finished. The problem is we don't want negative x. We want regular x. So how would I get rid of that negative sign? Well, I would divide both sides by -1. Dividing 0 by -1 still leaves me with 0, but there's a rule you have to remember of inequalities, and I wrote it over here for you. If at any time you divide or multiply by a negative in an inequality problem, you have to flip the inequality. So because I divided both sides by a negative number, instead of it saying greater than, it's going to switch to less than. So what happens when I make my number line, and I should have had a line under this, I'm sorry. I should have had a line. It's always equal to with square roots. I'm going to put a solid circle again on 0, but instead of shading to the right, I need to shade to the left because it says less than or equal to. I'm still going to put my 2 fingers, but my left finger is not on a solid circle. My left finger is on an arrowhead on the left-hand side. Anytime you have an arrowhead on the left-hand side, that is negative infinity. My right finger is on 0. And by using your left and your right finger like I'm doing here and putting it on the beginning and the end of the number line, you always end up with the numbers and the symbols in the right order, because if you had put 0 first and negative infinity second, you would actually get it marked wrong in ALEKS. The smaller number always has to go on the left, and the bigger number or symbol, depending on what we're dealing with, always has to go on the right. Negative infinity is smaller than 0. It goes left to right. Negative infinity would get a parenthesis and 0 would get a bracket. So using your 2 fingers as I'm showing you and sort of tracing it down to make your interval is helpful because your numbers and your symbols end up being in the right order. And then you're able to put in your parenthesis and your bracket accordingly. So that has to do with domain. And then I just want to do one last one actually before I jump over to graphing. Make sure I have my papers in the right order here. All right. 40 minus 8x, I wanted to revisit when we have an entire square root. So remember, the rule is you take whatever is under the square root and you set it to greater than or equal to 0. So in this case, I do in fact take the entire thing and set it to greater than or equal to 0. I would subtract 40 on both sides because I'm solving for x. I get negative 8x is greater than or equal to negative 40. I would then divide by negative 8. And this is my final answer. X, not greater than or equal to anymore, but less than or equal to, because I'm dividing. It has nothing to do with your final answer. Some people think, but my final answer is not negative. The rule is if you divide both sides, or multiply, but in this case we're dividing, by a negative, that's when you flip it. I didn't flip it here because I was subtracting on both sides. The rule is if you multiply or divide by something that's negative, you have to flip the inequality symbol. I'm going to make a little number line over here. I'm going to put my 0 and I'm just going to put 5 in. I have a solid circle on 5 and I want less than, so I'm going to the left. I take my 2 fingers, left and right. My left finger is on negative infinity. My right finger is on 5. Negative infinity gets a parenthesis and the 5 gets a bracket. And that would be your final answer in interval notation. So that's how you find domain restrictions. We're also going to use that very first step of what we were just doing by setting the square root greater than or equal to 0, and that is the first step of graphing as well. And I'll explain why with some steps down below. So our last part of this video, we're going to do 3 problems where we look at graphing a square root. So I wrote down a few steps. You're welcome to copy these down. The first thing you have to do when you're graphing a square root is focus on the square root and set it to greater than or equal to 0. And what this does is it helps us find the leftmost point. So you may not know this, but every graph has a picture. Like parabolas, for example, they look like U-shape. Square roots, when you graph them, always look something like this. It has an endpoint and it goes up to the side with an arrow, one single arrowhead. It has to do with the fact that like a parabola goes in two directions, because parabolas, you can have positives and negatives, but with square roots, we have a lot of restrictions because remember, we can't take the square root of a negative. So a square root function often looks something like this, where it's a little arrow going to the right. Sometimes it will be down here, but it has a specific endpoint. The endpoint is where it starts, and then it goes on forever in the other direction. So finding this endpoint right here is the same thing we did when we were finding restrictions or looking for the domain. And after you find this endpoint, you have to choose 3 other numbers because they want you to plot 4 points. The first point we plot is this endpoint. And then the 3 other points just have to be to the right of that. So let's say right here that this was x, the x value right here was 1. I might choose something like 2, 3, 4 for my next 3 numbers. I'm going to show you how I pick those numbers in a minute. There's actually a kind of a shortcut behind it. But whatever this leftmost endpoint is, you always want to choose 3 numbers on the right. If this was x is 1, I wouldn't want to choose 0 to plug in because that's smaller than 1. If this x value right here was 4, I could choose things like 5, 6, 7, 8, 9, 10. If it was 4, I would not want to choose 3, 2, 1, or 0 because that's to the left. So just so you know. All right, so let's look at one together. So this is the original. Step 1. Take whatever is under the square root and set it to greater than or equal to 0. X is greater than or equal to 0. Okay? How do I solve that? Well, I get 0. So I know x is 0. What happens if I plug in 0 here? I need a point. Okay, so this is what I'm getting at. There's nothing I can do here. If I set x is greater than or equal to 0, I get 0 as my x value. So this is just saying that whatever you plug in here can be 0 or larger. So start with the number that you get here. So 0 is what I'm going to start with. What is the square root of 0? 0, and then 0 take away 5 is negative 5. This is my leftmost point. So once you get x isolated, this is the first number that you're going to plug in because this is what helps you find the leftmost point. I'm going to make a little sketch over here. 0, negative 5 is right here, so I know that my parabola, my square root starts right here and goes somewhere to the right. So what are some numbers to the right of 0? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. However, because I have to plug whatever numbers I choose into this original problem, I'm going to do 3 of them, 3 points. I want to make sure whatever I choose works out nicely. I would never choose to plug in 2 here because I can't take the square root of 2 without getting a decimal. So what I usually tell students is sometimes you have to play around with the 3 numbers you choose. Let's start with the first number bigger than 0. The first number bigger than 0 is 1. Can you take the square root of 1 easily? Yes. So I'm going to use 1. So let's talk about it. The square root of 1 is 1. And 1 take away 5 is negative 4. So I could plot the point 1, negative 4. Now 2 I would not use because I can't take the square root of 2. Then the next number I could choose is 3, but I wouldn't use that either because 3 is not a perfect square. Then 4. I am going to use 4 because 4 is a perfect square. The square root of 4 is 2, and 2 take away 5 is negative 3. There, oops, it's off there a little bit. My graph is a little off, but that's okay. I would then go 5, 6, 7, 8. None of those are perfect squares. That's not going to help me. 9 is my next perfect square. The square root of 9 is 3, and 3 minus 5 is negative 2. So that's going to put me way over here somewhere. This is just a sketch. I'm not doing my graph to scale, but that's what it would look like. 9, negative 2. So while you think you could choose any numbers you want, I can tell you if the x is under here alone, which it is, you can always use the numbers 0, 1, 4, 9. That will always work when x is alone because those are perfect squares. But if x is not alone underneath, that's when it is a little bit more involved. And for my last two examples, that's what I'm going to show you, is what happens when it's not just x underneath. You kind of have to do a little mental math to figure out what numbers to use. But you know, what I will say is underneath, if you can get it to be a 0, a 1, a 4, a 9, our next perfect square after 9 would be 16, 25. Those are all things that are easy to graph. Now these graphs can get a little bit big, so you want to start with smaller numbers. So let's look at a few more, and then I will pause this video and make a new one for the next concept. So I'm going to take what's underneath the square root. I'm going to make a little sketch over here. Underneath my square root this time is x minus 1, and I'm setting it to greater than or equal to 0. I could also use a t-chart here. I'm going to add 1 to both sides, and I know that x has to be greater than or equal to 1. So I can plug in any numbers I want to this side of the table. This is my x values. We choose our x values. We're finding our y values. I can plug any number into this equation that I want as long as it's 1 or larger. You always want to choose the number you get here as your first one. So I'm going to use 1. Why? Because when I plug it in, it works out nicely. 1 minus 1 is 0, and the square root of 0 is 0. So my very first plotted point is right here. That is my leftmost point. And again, I have to use 1 because it has to do with how we find the domain. When you set whatever is underneath the square root to greater than or equal to 0, whatever you get right here has to be the first number you plug in your table. Now, what you plug in after that can vary, and you have to play around with your math facts. So the next number after 1 would be 2. So what I'm going to do is I'm going to come up here and see if 2 would work easily or not. What happens if I do plug in 2? 2 minus 1 is 1. Can I take the square root of 1? Yes. So 2 is going to work. 2 minus 1 is 1, and the square root of 1 is 1. So 2, 1 is an easy one to work with. Now what comes after 2? 3. If I put a 3 right here, 3 minus 1 is 2, and it is not easy to take the square root of that. So basically, I keep going up until I find something that could work nicely. Some of you will find these very quickly. What your goal is to get whatever is underneath to be a perfect square. So I know that the next perfect square after 1, remember, if you think of your perfect square list, you could even keep this handy. I need to get a 1, a 4, a 9, or a 16 underneath this. How could I get 4 underneath? What would I have to put right here to make underneath a 4? Well, I know it would be 5. Because 5 minus 1 is 4, and the square root of 4 is 2. And there's my second point. Technically my third if you count the first one. After 4, what's my next perfect square? 9. What would I put here that would give me a 9 underneath? 10. 10 minus 1 is 9, and the square root of 9 is 3. And this is what I would graph. And again, my graph is going to go off to the right here. It gets farther and farther away. Now let's look at one last one. Here I have a number outside of the square root. That is okay. I'm still taking whatever is underneath and setting it to greater than or equal to 0. So x plus 4. I'm subtracting 4. X has to be greater than or equal to negative 4. Has to be. So my first number in my table has to be whatever this is, negative 4. Negative 4 plus 4 is 0. The square root of 0 is 0, and 0 times 2 is still just 0. So that is my first leftmost endpoint. Negative 4, 0. Now, think about my perfect square list here. Right here, sorry. What can I do here so that I get a 1 underneath? And I would encourage you not to go higher yet. Always start with the smaller one if you can. What plus 4 would give me 1? Well, hopefully you know negative 3. Negative 3 plus 4 is 1. The square root of 1 is 1. And 1 times 2 is 2. Then what could I put under here that would give me 4? What plus 4 is 4? Well, 0. 0 plus 4 is 4. The square root of 4 is 2, and the 2 on the outside with the 2 next to it becomes 4. So I'll do that one more time. 0 plus 4 is 4. The square root of 4 is 2, and 2 times 2 happens to be 4. And then the last one, what would I plug in here so that I end up with a 9 underneath? Well, 5 plus 4. 5 plus 4 is 9. The square root of 9 is 3. And 3 times 2 happens to be 6. And those would be my 4 numbers that I could then plot and graph. I'm just doing 2 of them to show you the sketch, but you would have to do all 4 of them in ALEKS. So the key is finding the leftmost point and then choosing 3 things to the right. Again, if you're not great with the adding and subtracting or figuring, having this little sheet here would be very helpful. One time I was working with a student and she's like, I just don't get how you're coming up with these numbers in your table. It's very easy to come up with the numbers when it's just the square root of x, like what I had here. When underneath is only a square root, you can just choose 0, 1, 4, 9. But when it's not just a square root and it has something else with it, like it does here and here, unfortunately you can't do that and you have to find numbers to choose. And your goal always is going to be make sure whatever you have underneath is either 0, 1, 4, 9, 16, 25, perfect squares. So I hope that helps with domains and graphing, and any other questions you have about either, feel free to reach out and ask. Have a great day.